Hello info person, this is Anton, and today we're going to discuss a somewhat interesting research that focuses on a new way to try to discover some kind of an extraterrestrial intelligence out there. Research that doesn't look for humans for inspiration, but instead focuses on a glowing beetle that we're all familiar with, a firefly. And so today we're going to discuss this study right here that uses a firefly-inspired model in order to search for alien intelligence. And so let's talk about this in a bit more detail, but I guess let's first start with what problem this is trying to solve and why this is actually kind of interesting. And the main problem is, of course, in our biases. Because for decades, the search for extraterrestrial intelligence has been based on what scientists refer to as anthropocentric bias. Essentially, we're looking for aliens that we're hoping are going to be similar to us. Or basically, we're assuming that real life is just like some kind of a Star Trek episode. We're mostly focused on searching for radio waves, because that's how we communicate on our own planet. And we also send messages based on mathematics and specifically prime numbers, because we understand math and we assume aliens would as well. But as our technology changes, moving away from very loud broadcasts to a much quieter satellite communication and even fiber optic signals, technically this makes Earth a lot more difficult to detect from the outside, suggesting that looking for a specific human-like technology might create an extremely narrow window. And so to find something truly alien, researchers behind the study from Arizona State University argued for a much broader approach, one based on a more universal law of evolution and even communication seen across different species right here on our own planet. And in this case, fireflies seem to offer a perfect case study, mostly because, unlike other animals, they actually seem to rely on a kind of a binary system, or basically they use on-off signaling system that is surprisingly similar to the human Morse code, or even computer language. As a matter of fact, the website from the American Museum for Natural History even has these simulations that kind of show you how a typical firefly communicates. And as you might be aware, technically you can communicate with fireflies by using a simple flashlight, or basically by producing the right kind of a pattern. There's a very high chance that some fireflies will try to respond back. And so this is a very interesting communication method. And it's even more interesting because it seems to be species-specific. For example, we know of at least 2,400 different species of fireflies, and each one of them seems to have their own pattern of flashes, a very specific rhythm that's usually used to help mates find each other in the dark. So essentially this is a reproduction-based communication. But at the heart of firefly communication is of course the phenomenon known as bioluminescence. Here we have a chemical reaction occurring inside a specialized organ referred to as the lantern, and it involves a very specific protein or enzyme referred to as a luciferase. It basically requires magnesium, ATP, and oxygen. But intriguingly, it produces what's known as cold light. Or in other words, it produces almost no energy and almost no heat. And that's of course essential for fireflies' survival. In order to produce so much light, a standard light bulb producing just as much light would very likely burn the firefly, preventing this type of communication from happening. But based on the years of research, scientists realized that this seems to be an evolved behavior. It actually started as something entirely different and was previously a type of a warning signal that larvae used in order to tell predators that whatever they were about to eat was not tasty. But over millions of years of evolution, fireflies eventually started to use this for mating and communication, and not just as a warning signal. And remarkably, this actually solves a very important problem referred to as the cocktail party problem. Or basically here they found a way to communicate even though there is so much other noise going on around them. And so in the environment where thousands of individuals and multiple species are flashing simultaneously, fireflies evolved a very specific signal that's still being heard by other fireflies amidst all of this background noise. And they solved this problem in two distinct strategies. First, as I mentioned, they have a kind of a species-specific rhythm. Every flashing species has a very unique pattern defined by the duration, timing, and repetition of flashes. And these patterns allow males and females to only interact with the same species, even in complete darkness or if there are other signals around. But the other strategy is collective synchronization. And so here, in some very spectacular instances, thousands and thousands of male fireflies will actually flash in unison. And this type of cooperation usually amplifies the signal, making the group's presence much more detectable to a lot of different females on the ground. And so here they evolved a way to make their signals maximally distinct from anything else. And so here scientists took a very similar logical approach and then applied it to space communication as well. But instead of trying to look for some kind of a mathematical pattern or some kind of a bizarre radio signal, they instead proposed focusing on the signal's structure and specifically how much the signal stands out against the natural background of the galaxy. And for this particular study, they decided to focus on pulsars, or basically how much pulsars stand out from the astronomical background, and if there's maybe something we discovered here as well. And here pulsars make quite a lot of sense. Just as a reminder, pulsars are extremely fast spinning neutron stars that usually produce signals with extreme periodicity and very often several times per second. But because they are so regular, they actually resemble what we might expect from some kind of an artificial signal as well. So here imagine some kind of a space firefly basically. And so the team behind the study created a model that tries to calculate the overall cost for some kind of an artificial signal out there. And here it's based on two principles. First, similarity. How much does the signal overlap with various known natural pulsars? But second is also energy. How much power would it take to send such a signal? And so by minimizing the cost of both of these properties, the model then generates a kind of an optimized signal designed to be as different from a pulsar as possible while still using the least amount of energy. In other words, it would be a signal resembling a pulsar, but being different enough that some other species out there would actually recognize this as artificial and thus maybe want to respond or communicate. With the next step being trying to compare this to actual signals from real pulsars just to see what they can actually discover. And so when this was tested against a database of 158 real pulsars, mostly within about 20,000 light years away from us, the results were quite striking. Here they did discover that the optimized artificial signals were much more distinct than nearly the entire pulsar population. Specifically, the optimized signals had a much lower cost than approximately 99.8% of pulsars they studied. And out of 158 targets, only 2 pulsars, both of them actually spinning ridiculously fast, almost at the limit of how fast pulsars can spin, seem to have structures similar to these artificial signals. But in both cases, these are more likely to be naturally occurring millisecond pulsars that seem to have formed through a process referred to as accretion. So here they're not actually saying that this is aliens. They're just saying that 2 of them resemble the artificial signals the most. And so this research is actually quite exciting because it does focus on something a lot different. Instead of focusing on some kind of a complex alien communication or some kind of a math equation, they seem to suggest that maybe the signals we're going to encounter are going to be kind of similar to other animals on our own planet. They might involve some kind of a signal that stands out against a crowded background and may involve a much lower cost, but resembles something that is natural, involving a lot of rhythm and repetition. But if it does involve pulsar-like communication, it would also involve some kind of a super advanced species. Basically, to create something that resembles a pulsar, these aliens would still require an immense amount of power. Here this is of course the famous Kardashev scale, and would require a Type 2 civilization at least, the one that's able to harness the total energy of the star and then convert it to send a signal. But ultimately, the study is also important because it reminds us that communication is actually a fundamental feature of a lot of different types of life. And so if alien life does exist out there, we assume that it's going to be doing something very similar too. In this case though, by looking at how fireflies talk to each other, we might find a key on how to recognize some kind of a hello sign from a different star out there. And so quite an intriguing study. But the thing is, at least for now, that's kind of all we know. In the last few years, we've discussed quite a few of these study propositions involving some other topics, and you can find some of them in the description below. But we'll definitely come back and discuss some other studies and some really intriguing propositions in some of the future videos as well. And so subscribe, come back tomorrow to learn something else. Check out the links for the playlist in the description below. Maybe support this channel on Patreon, where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.